how would you reflect this shape in the mirror line?
Um, the you do the points, like the main points.
Mm-hmm.
So yeah, there's 3 points, and then you put it on the opposite side.
So how many squares away from the mirror line would the blue one be?
1.
Mm-hmm. Red one?
The red one would be 3.
2, 3. Green one?
Green one would also be 3.
2, 3. And straight across. And last thing you do?
You connect them up.
That's it. Join them up. Right, you already good for that thing. How about if it's exactly on the mirror line?
So you do the main points again. So it'll be the blue dot. It will be two squares up, and then you just connect it to the other dot there.
Yeah, so they will be 0 away. They're basically 0 away
Yeah.
from the line, and so they stay where they are. They're exactly the same as where they were before. Well done. Okay. How would you do this one?
Reflect triangle on the lines AB. Label the new triangles. Okay. Reflect triangle in the line AB. Label the new triangles. Okay. When it says in the line, does it mean it has to be past it? Or
No, so it means that this line AB is the mirror line.
oh, okay. So you do the point, and the blue point is 1 away from the
Mirror line?
mirror line. The red point is also 1 away from the mirror line.
Mm-hmm.
And the green point is 3 away from the mirror line.
2, 3. And then we join them up. And so even though there was all this other stuff going on, y-axis, x-axis, it's exactly the same thing. Oh, what does this say?
Label the new triangle S. So that triangle will now be S.
That's it. So you have to write S. Very good. What is this?
Reflect the shaded triangle on the y-axis. Okay. So you will have to do the points. So the first point is, I think, that 2 away from the mirror line.
Well done. So 1, 2. And
then yeah.
And I notice this is -2 and the y-axis is at 0. So this is -2, so this will be +2. These are -4, so over here they'll be
+4.
Yeah. Oops. Red is up there. Green is down there, and it's just the same as before. So the trick with this one is knowing that the y-axis is this line in the middle with the arrow that says y. Hang on. Yeah, we didn't have to label it. This is the same idea, except there are 4 sides. But I think it's just the same idea. There's just 4 corners. So you do each vertex, each corner. That one's 2 away. That one's 0 away. That one's 2 away. That one is 0 away. And then you just join them up. Yeah.
Okay.
There we go.
Yeah.
This one is the same. This one is so easy. Same. They get a bit trickier. Okay, how about this one?
Okay. Reflect shape P in the line X equals -1. In the line X equals -1.
So if I go back to this one, the line AB, this goes through the x-axis. Let's see, so if this is 0, 1, 2, so that's 1, that's 2, and so this line is x equals 2 because it goes through the x-axis at 2 for all its points. So 0, 2, sorry, 2, 0, 2, 1, 2, 2, 2 minus 1. So that's x equals 2. What would be the equation for this line here?
Would it be x equals 6?
No. So to the right is 1, and so to the left?
Is
1 to the left from 0?
2? No, -1.
So minus 1. So that's -1. Any idea about this one?
Then that'll be -3.
Yes, and so this line is x equals -3.
Okay.
And so, how about this?
Okay. So line x equals -1. Okay. So. Okay, and there that. Yeah. So then that's the mirror line. So it would be. The first point would be. How much is 2 past the mirror line?
So that's the y-axis. You see how, so this is the x-axis, and we want x equals -1.
Yes.
And so it goes through the x-axis at -1, and it's straight up and down. And so how many spaces away are the first corners?
3.
3 away, yes. So 1, 2, 3, and so 1, 2, 3. And the other corners?
The red one is also 3. The green one is 4 away.
So it's 4 away from 0, but this is x equals -1.
Oh, so it would be -6.
Correct. And so the other one would be -6 as well. Straight across, and then you just join those up. Well done. So x equals -1. It goes through the x-axis at -1, and it is vertical, straight up and down. Any questions there?
No.
Well done. That is okay. Okay. And then sometimes they have more than 4 corners, but it's the same idea. So just make a dot for each one and count. 1, 2, 3, 4. So 1, 2, 3, 4. And just do that for all of them. And then you join them up at the end. And I think you'll be okay for that one. If you were sitting beside me, I might make you draw it, but I think you'd get it right.
Okay.
So you can see even here how many corners are there. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8, but it's going to be the same thing. I'm kind of cheating, just guessing, but it looks right. Okay, that's in the wrong place. Let's put a star there. So that's same. So the shapes are a bit weird, but it's the same idea. Okay, how do we do this? Diagonal reflection.
3. Oh. So when you place the points, so the points also have to be diagonal.
Yep.
Okay. So oh gosh, this is hard.
So this time, the way you do this is how many diagonals away from the line is the blue?
1?
It's like half.
Yeah, half.
And so you go half the other side and you make a dot. How about the green?
That is 1.5.
Yes, so 1.5, and so the other side, a half and 1. And the red?
That is 2.5.
Yes, and so the red is 2.5 away from it diagonally, and so you do another 1/2 and 2 on the other side. And the last thing you do,
you connect them.
yes, you join them up. And so if it's a diagonal line, you just reflect diagonally, exactly the same as before.
Oh,
well done. And so this red one, that's 2.5 diagonals away, so it's 2.5 diagonals away on the other side, 2.5. And the blue one was 1/2, so that's 1/2. Tricky thing. Okay, how about this one?
rectangle E is a reflection for rectangle D. On the grid, draw the mirror line label to mirror line M. Rectangle E is a reflection. On the grid, draw. Okay, the mirror line will just go in the very middle between D and E.
That's it. And so
And
mirror
then,
line goes
then
there.
you label it M.
And you label it M. There we go. Okay, what does this mean?
Describe fairly the single transformation that maps shape A onto shape B. Describe the single transformation that maps shape A. What?
Do you know what it's called?
No.
What these things are called that we were doing?
No.
These are called a reflection.
Okay.
And you have to say a reflection in the what for this one?
Reflection in the grid.
Which line? What mirror line is it?
x equals 0.
Well done. Reflection in the line x equals 0. And that's the same as a reflection in the y-axis. Same thing. If you had said y-axis, that's also correct. Okay, how about this one?
On the grid sheet in the 1 more square so that the complete shape has one line of symmetry. You take the 1 more square so the complete shape it will be the line on the right side.
Here?
Yeah.
Okay, so 1 square there. And that will have one line of symmetry down the middle.
Mm-hmm.
So you've got 3 squares there, 3 squares there. Yes, there's a few different ways you can do it. That's good. So you can put one here, which is what we did. Or you can put one there, or you can put one there. But just one of each. Shade in 1 more square. Well done. This one you're going to be okay. Okay, how about this?
Draw all the lines of symmetry on this rectangle. Draw all the lines of symmetry on this rectangle. Okay, so do you have to draw the line or draw another rectangle?
Draw the mirror line.
Okay, so the mirror line would go close to the rectangle.
Like, is it... So you have to make it reflect with itself. Like, cut it in half.
Cut in half. Oh, okay. So it will be in the middle and then...
Going which way? Up or down, left or right?
Up.
So you've got one like that. Is that it?
Yeah.
And why did they say this one?
Draw all the lines. Okay. So it means you have to draw all the different ways.
Okay.
So there could be a sideways one.
Well done.
Or diagonal.
Diagonal would be only for a square.
Okay.
Or like if all the sides are the same length. So that's it. All the lines of symmetry is a clue, meaning there's more than one. And that's it. So there's no diagonal for that one. Okay, how about this one?
Draw a line of symmetry on this pentagon. Okay, just one. So straight through the middle.
Yeah, so you can go straight there. And do you know what regular means?
Yeah, like because pentagon is a shape with 5 sides, but this is what a regular pentagon looks like.
Regular means all sides are the same length. So all sides are the same length. And so, do you know how many lines of symmetry this will have altogether?
2.
If it's a regular shape, then you'll be able to do it through any 2 vertexes, any 2 corners. And so 1, 2, 3. That one's a bit off. And so, hang on, is that one? No, it should be like that. In the middle to one end. In the middle to one corner. In the middle to one corner. And then in the middle to one corner. And so how many lines is that?
1, 2, 3, 5.
So that's 5 lines. Yeah, so in total that has 5 lines. And so if it's 5 sides and it's regular, then it will be 5 lines of symmetry. But the answer to this question, they just wanted 1. And so the answer for this question is just 1 line, and any of those 5. But I just thought I would show you that it could have 5 in total because it has 5 sides and they're all the same length.
Okay.
Any questions about that?
Nope.
Okay. Okay, how about this one?
This quadrilateral has all 4 sides the same length. On the shape, draw all the lines of symmetry. Okay, so there's one going from the top to the bottom,
Mm-hmm.
then one going sideways.
That's it. Is that all of them?
Can you go diagonal?
All 4 sides are the same length, and so can you go diagonally?
Yes.
Yes. If all the sides are the same length, and it has 4 sides, then it will have 4 lines of symmetry. Wait, they tricked me. 1, 2, 3, 4. This quadrilateral has all 4 sides the same length. Looks like it has 4 to me. Let's see this one. It says all 4 are the same length. Did I put this in the right place? On the shape, draw all the lines of symmetry. So that one, halfway. That looks very symmetrical to me. I think there's 4. I wonder. Okay, how about this? Hang on, what type of shape was that? That's a rhombus. Should have thought. Okay, this one.
Which one of these shapes has exactly 2 lines of symmetry? D.
2 lines of symmetry. It looks like D. I see 2. And are there only 2? I think so. D. 1 mark. Well done. Okay, how about this one?
No lines of symmetry. That would be what? What is that? Is it F?
F, I think, has 1 down the middle.
Oh yeah. All of them have 1, 2, 1, 2, 1. What? All of them have a line of symmetry.
I believe the answer is A.
A?
If you go straight down, that won't fold across. Like this point down the bottom will be sticking out here. If you fold this way, that point goes in that space, and the sides aren't the same length, and so diagonal won't work either. So I believe it is A. Yeah, A, 1 mark. And so this one, you can see that that's got 2.
Yeah.
1. That's got 3. This has 8. And this has 6, so it has to be that first one. Okay, how about this?
And the number of lines of symmetry for this symbol. Um, one. One?
I think it's 1. Straight down the middle. 1. You're okay for that. Symmetry. Okay, how about this?
Okay. One through the middle.
Going which way?
Up or down. Up and down. And then one going sideways.
I think that's it. Any diagonals?
No.
I think so. 2 lines of symmetry. Okay, how about this?
How many lines of symmetry does shape C have? 1.
Mm-hmm.
Draw all the lines of symmetry on this shape. One through the middle.
Okay.
One from the side. One diagonal.
Like that?
Yeah. And then another diagonal.
Uh-huh.
And I think that's it.
I think that's it. That's it. How about this?
Draw the lines of symmetry on this triangle. One through the middle.
Say it again, sorry.
One through the middle.
Straight down.
Yeah.
They all go through the middle.
Is there another one going diagonal?
Are all the sides the same length? Oh, it doesn't tell us. Oh, it has to tell us. Okay, so if it's all 3 sides the same length, then it would be 3. This looks like it's isosceles, and so it looks like only 2 are the same length, and so it would just be that 1. Okay, how about this?
Okay. On the grid, draw the line of symmetry. Draw the line of symmetry of the quadrilateral. One going down. And I think
Yep,
that's it.
Okay, how about this?
One of the patterns has exactly 1 line of symmetry. Write down the letter of this pattern. Write down the letter of this pattern.
Let it go through the sky.
A.
A, yes. I believe it's going across. So it is A. Very good. This one, I think you'd be okay. Okay, how about this?
On the shape below. The shape below has a few squares. Possible. So the dotted line is a line of symmetry. Okay, so you shade one at the top next to the line.
Mm-hmm.
And on the other side, the other one between the 2 squares.
Mm-hmm.
And then and then at the bottom there's one near the line, straight down. And then there's another one next to it between the 2 squares. And then at the top there's one gap between near the edges, and on the other side there's also one.
That's
And
it.
I think that's symmetry.
Yep, so you just have to shade in all the ones around the edge. And there we go. Okay, how about this?
On the square, draw all the lines of symmetry. One through the middle, one down, one sideways, one diagonal, and another one diagonal. And that's it.
And why was there 2 diagonals for this one, but not a rectangle?
Because all the sides are the same.
Very good. That's it. Okay, how about this?
Write down the letter of a shape that has exactly one line of symmetry. Oh, God. C?
One line of symmetry C. The letter of a shape C, yep. And I think B as well. Yep, B or C. Okay, how about this?
Which of these shapes has exactly 2 lines of symmetry? Write down the letter of the shape. That would be A.
2 lines of symmetry. A, well done. That one's okay. That's okay. Okay. Any idea about this?
This quadrilateral has all 4 sides the same length. Write down the special name of this quadrilateral. A rhombus.
Well done. It's a rhombus. All 4 sides are the same length, and it's not a square. Rhombus. Okay, how about this one?
And the mathematical name of this quadrilateral, is it a is that my what is the name? Is it trapezium?
Well done. It looks like you could jump on it like a trampoline. Trapezium. Very good. Trapezium. Okay, how about this?
Octagon.
Yep, 8 sides, octopus, octagon. How about this one?
Over. Shape G is a polygon, not the mathematical name of this polygon. How many sides does it have? That is a hexagon.
Well done. 6 sides. That's a hexagon. X in 6, X in hexagon. How about this?
I don't know. I forgot the name of this. Is that a I don't know the mathematical name of this type of quadrilateral. What is this? What is this quadrilateral? Parallelogram.
Well done. 2 pairs of parallel sides. Parallelogram. And it's got 2 parallel L's in the middle. Parallelogram. That's okay. Parallelogram. Okay, how about this?
Pick one of these shapes is a parallelogram. C.
Yep. How about this?
G.
G. 6 sides. Okay, this one.
E.
E. Okay, how about this one? Draw a kite.
Two short lines at the top, two long lines at the bottom.
Yes, and so it's a bit like a rhombus, except it's got 2 pairs of equal sides, but not all are equal. And it looks like a kite. That is right. Let's come back to this one. Let's come back to this one. Okay, any idea what this is about?
Here is what is the order of the rotational symmetry of this pentagon? What is the order of rotational symmetry? What's rotational symmetry?
So if you were to spin it around the middle, how many times would it fit perfectly onto itself? Any idea about that?
5 times.
Well done, 5 times. So its order of rotational symmetry is 5 because it's a regular pentagon. All 5 sides are the same length. Okay, how about this one?
G1 must square to make a pattern of rotational symmetry. Okay, it would be another block on the bottom, like in the middle.
Left or right?
Right.
Yes, well done. So it'll be that block there. And that way, if you were to spin this around the middle, it would fit perfectly back onto itself 4 different times. How about this one?
Write down the order of the rotation. Would it be 4?
So this point here, if you were to spin it around the center, so this blue point, it would fit perfectly back onto here. but it wouldn't fit to the other one. Like it wouldn't fit perfectly this way.
Oh, so it'll be 2.
Yeah, so that one's just 2. Okay, how about this one?
Write down the order of rotational symmetry of shape E. 8.
Yes, because it is irregular, I think. 8. Okay, this one.
Write down the order of rotational symmetry in this quadrilateral. 2.
Yeah, 2. Very good. This one.
Write down the order of rotational symmetry. 6.
Well done. Okay, how about this?
2 of the letters have rotational symmetry order of 2. Right, E and B.
B and B. That's going to be okay. So do you know how to do rotations?
No.
Rotations. It's easier to do it with tracing paper. So I think I'd save this for school, where you do tracing paper. So you would just put down 90 degrees anti-clockwise, about 0, 1. So you'd put down a big piece of tracing paper. You would trace your shape. So let's say trace the 4 corners. And then you would put the point on 0, 1, and you would spin everything 90 degrees anti-clockwise. And so it would, let me just spin this 90 degrees anti-clockwise. So it would end up looking like that. That's a 90 degrees anti-clockwise spin.
Okay.
But you would spin it around the point 0, 1. So the sharp of your compass would go there. But it's easier to just do that one with tracing paper. Okay, how about this?
Write down the order of rotational symmetry of pattern C. That would be 4.
I don't think so. If you were to spin that around the middle,
2.
I think it's 2, because it's not 4-way symmetrical. It's just 2. Yeah. Okay. Oof, that's weird. How about this one?
Write down the order of rotational symmetry. Is that 2?
I think this is 2 as well. Yeah. Okay, rectangle.
Write down the order of rotational symmetry for the rectangle. Would that be 2?
I think that's 2. It's the first time we saw a rectangle. Okay, how about this?
2 of these shapes have rotational symmetry of order 2 and no lines of symmetry. No lines of symmetry. Would that be B and C?
B has a line of symmetry.
Oh, both of them have. Oh, no, I messed up. It would be G and E.
I think so. G. Well done. So this is a rotation. Any idea how you do this one?
Rotate the shape equal a quarter turn for close about there. Rotate the shape a quarter turn. What?
So a quarter turn clockwise. Do you know how you do that?
No.
So you would use your tracing paper again, but a quarter of a turn would be like that, and clockwise is in that direction. And so it would end up looking like that. But it's just easier to do it with your tracing paper. I'd save it for the tracing paper. Enlargements. Let's do something. Any idea how you do this?
Draw an enlargement of the shape. Scale. Understood. Draw an enlargement of the shape with a scale factor of 3. Okay, so it would be so it would be around 6 blocks tall.
Yeah.
6 plus 2, 9 squares on the bottom.
Yeah.
And 6 squares on the top. Then connect it.
Well done. That's great. How about this one?
Rectangle cubes and that is a scale factor of 2.
Scale factor 2. This one?
Shape B is an enlargement of shape A. Write down the scale factor of the enlargement. Okay, the scale factor. Is it 2 again?
I think it's 2. So these are all past exam questions. They're all very similar. This one, just draw that shape. Let's just see. I did that. That's gonna be okay. And yeah, so let's just do a recap. So reflections. How do you do a reflection?
Reflection. You just copy the dots on the other side of the mirror line.
That's it. You just count the sides. Sometimes it's 0 away, and so it's going to be the same spot twice. This one. Yeah, why is the equation of the other line x equals minus 3?
Because it is on the x-axis and it is on the number minus 3.
And so what would be the equation for this line, this blue line?
X equals 5.
Very good. That's x equals 5. So there's so these are all the past exam questions. There's more of them. They get more complicated and stuff, but it's just the same idea. So if you're able to do, one, you're able to do all. This one was a bit tricky because they said x equals minus 1, but the only tricky bit is to draw on that line. Once you have that, then it's the same, and don't get confused by the y-axis. But other than that, it's okay. So then you have more than 4 sides, more than 4 vertices, but it's the same idea. Just as easy. Hang on a second. Okay, 1, 2, there we go. Yes. How do you do a diagonal reflection?
You just copy how many diagonal squares it took and do it on the other side.
That's it. It's literally just a diagonal reflection. So the mirror line is just halfway between the two shapes. That's okay. What did they mean by this question?
That's great. What did they mean? They just meant what the x-axis line was.
Yes. So for this one, you have to say it's a reflection, and then you have to say the equation of the line that it's a reflection in. So it's a 2-mark question, so you have to say two things. One is reflection, and the other is in the line x equals 0. So this one, yeah, you just had to shade in a shape to make it symmetrical. Shade in a square, and there was a few of them. You could pick any. Yes. Why does this one have a total of 5 lines of symmetry?
Because all the signs are equal.
Yes. And how do you know all 5 sides are equal?
Because it's a regular pentagon.
Correct. So it's regular, so they're all the same length. So this was for doing it for lots and lots of different shapes. Tricky shapes. Yeah, they got trickier and trickier. Trickier. You were good for the names of shapes. You were very good. You knew them all. Kite, you were good for that. Yes. What is rotational symmetry, and why was this in 5?
What is it? It is when you spin the shape around and to see if it will fit in the perfect slot.
Yes, like back onto itself. That's it. So that's why this one had a rotational symmetry of 4. You could spin it 4 times about its center, and it would fit perfectly onto itself. These ones look like they'd have 4, but they only have 2, so watch out for that one. If it's a regular, then it's going to have the same number. These ones were good. This one I'll just save for tracing paper. It'll just be easier to do it with tracing paper. That one was good. So there's lots of different ways to do shapes. They do it with squares, and then they started putting 2 things together. So it has to have rotational symmetry of 2 and no lines of symmetry. So mixing and matching. And then enlargements, yeah, you're pretty good for those. You just multiply all the sides by the scale factor. Yeah, how was that for you, Carlos?
That was good.
So any topic in particular you want to do next time, or should I pick?
You can pick.
Okay. Any questions for me in general?
No.
Alright, well done, Carlos. You did great. I look forward to chatting again next week.
Yeah.
Alright, have a good week. Goodbye.
Bye.